This is the first video in the series of videos where we will be learning Rust programming by solving exercises. I have chosen Rust by Practice Book because it provides awesome examples. So the first program would be on variables. Let's move on to the first program. The first exercise is about binding and mutability. Before that, let's look at the example to give you a little bit of an idea of how things happen in Rust programming language. Let is used to define variables, and we can specify the data type of a variable by a colon followed by the data type. For example, here it is unsigned 32-bit integer. There are different data types available. We will see that in a minute, but let's see what the exercise is. So the point says a variable can be used only if it has been initialized. In Rust, you cannot use a variable without a value, without a definition. So you must declare and define the variable before you can use it. So here, if you run the program, that's the best thing about this website, is that it allows you to run the program at hand, and you can make changes and run it. So you see that there is a warning, but we are not interested in that. We are interested in error. Error says that binding x isn't initialized. That means we are using x, but we haven't initialized it. So in order to fix this or to solve this exercise, what we have to do is initialize it. Now, if we compile this, we will only see a warning being because of this variable. Let's run it, and it should print success. Yes, so let's move on to the next exercise. It is about mutability. Use mute to mark a variable as mutable. In Rust, every variable you define is immutable. That is, you cannot change the value if you want to. So for example, if I have a variable x equals 1 and then I increment x, it should give an error. Yes, and it says that cannot assign twice to a mutable to an immutable variable. So in order to fix this issue, we have to make this variable a mutable variable. So let's add a keyword mute to fix this error. Now x is a mutable variable, that is, the value of this can be changed in the program. And another thing I would want to point out is that the compiler actually provides us help. So it actually suggests that you should add mute. This is one of the features, I will say, of the compiler of Rust. And if we run it now, it should print success. Yes. So let's move on to the next exercise. Scope is the range within the program for which the item is valid. A very basic concept of programming, that if x is defined in this scope, it should be accessible in this scope, and if y is defined in another scope, which is a smaller scope here, it should not be accessible outside this scope, outside this block of code. Let's run it and see what it produces. So yes, it is producing an error because we are using y here. So let's remove this because y is actually out of scope beyond this block, beyond this smaller block. So now it should run fine. Nope, gives another error. It is saying that you are asking for a value, but you're not providing it in this. So let's remove this too. Now it is going to work fine. All right, now let's move on to the next example or exercise. Here we are going to print world along with x. but x is not defined here. X is actually being defined here. Now you know that x should not be available beyond this block. So of course this is going to give an error. Let's run it first, see what happens. As expected, we have an error. Cannot find value x in this scope. It cannot find the variable x being defined in this scope. So either we can remove it to fix it, or maybe we can provide a value to it. I will remove it and then run it. It gives another error. Yes, this is one of the things I will explain later on, but you see what is happening is this println is a macro, and it is uh, asking for a value, because in this example, as you saw, that there was an x. So let's just remove it and call it a day, because I will explain this concept later. Let's run it now. It should print success. Shadowing. You can declare a new variable with the same name as a previous variable. Here we can say the first one is shadowed by the second. Of course, if we have a variable x in this scope, in the main scope, and then we have the same name variable x in another scope, in one of the inner scopes, so here this x will be shadowed by this one. So if we print the value here, it should actually not assert to 5 but 12, and here it should assert to 5 because this x has gone out of scope. Before that, let's just run this program and see what are the errors. Assertion left equal right failed. It says that left is 12 but right is 5. It's actually referring to this one. So let's fix this and say it's 12 because it is referring to this variable. Now we should also fix this here, because now x is not 12. This local variable has gone out of scope. So let's say it's 5 because 5 is the value of x in this scope, in the outer scope, and it should compile fine. But let's see what happens about this. All right, another thing we learned is that we can redefine a variable with another value using the let keyword. There are many exercises. Let us move to another. Remove a line in the code to make it compile. We have to remove a line. So it is making a variable, mutable variable x with a value of 1, and then we are reassigning the value x equal to 7. And then we are shadowing and rebinding. I don't know what that is, if that is even possible. Pretty sure it is going to throw an error here, but let's move on. We are assigning a value 4, and then we are reassigning this variable with a string. So let's see what happens when we compile this program. X is never read for 13. It's a warning, 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 error. This line cannot be possible, as I said. So I think this is the line we must remove, because it is reassigning, and it says that you cannot assign twice to immutable variable x. So let's remove this line. Now run it. Compile successfully. Another one thing that I noticed here is that we can reassign a variable with a different data type, and it actually shadows this integer data type with the string. Another thing you would notice is that we are not providing a data type to this variable y. What happens is that Rust infers it, but then the question is, what is the data type it is inferring? By default, it's going to be i32. So every value that we assign here, which is an integer, gets into assigned 32-bit integer. The next exercise is destructuring. We can use a pattern with let to destructure a tuple to separate variables. You can use shadowing or mutability. The idea here is that we can get x, the value 1 in x and 2 in y by this particular syntax, and we can actually increment here. I don't know if it's going to compile because everything we define in Rust is going to be immutable by default. So let's run this program. Cannot assign twice to immutable variable x, as I expected that it should be a mutable variable. And another thing is that this is another data type. It's called tuple or data structure. We will learn it somewhere here in the compound types. So let's just say that yes, we can destructure a tuple like this. Now it should compile okay because we have made it mutable. It gives another error. Must be attached to each individual binding. So again, you see that Rust is actually helping us how to fix this error. So it's saying that instead of this, you can make every one of them mutable. So I think that's what I will do because we are only modifying x. So let's remove a mute from here and add it here. Now it should compile fine. So one of the things that I left was data types. These are the possible data types, integer data types. We have different bits sizes, and there is this I size and U size. U is for unsigned, that is everything will be positive. U size is decided by which machine it is on. So maybe 32-bit on a 32-bit machine and 64-bit on a 64-bit machine. It depends. More data types are floating point. We have floating point F32 and F64. Boolean type. Then we have character type. Now character and strings are a bit complex, so we will learn them in detail afterwards. And then we have more complex data types such as tuple, which we actually destructured. One of the benefits of using tuples is that you can have different types. You can have elements of different types in the same tuple, such as this is a floating point number and this is an integer. The next is arrays. We have arrays, fixed size arrays. There are more complex types, and we are going to learn all of these. Don't worry, we will actually write programs using these. So let's call it a day.